In this video we're going to have a look at conjugate acids and bases, which is an extension of the Bronsted-Lowry theory we discussed in the previous video. And conjugate acids and bases is looking at whether the products of a acid-base reaction are themselves acidic or basic. To help illustrate this, we're going to look at one reaction in particular, and that's the reaction between acetic acid and carbonate ion to make acetate ion and hydrogen carbonate ion. And this is a reversible reaction as indicated by the double arrow, which means the reactants on the left will form the products, but then the products will also be able to react together to form the reactants again. Down the bottom I have visual representations of the two reactant molecules, which is the acetic acid on the left and it's got the carbonate ion on the right. When the Ford's reaction happens, the acetic acid is going to lose this H+, because it is going to donate it to the hydrogen carbonate. So this is our justification for saying that the first substance was an acid and that the carbonate is a base because it accepts the proton. But like I said, this is a reversible reaction. What's currently shown down here is the two products, acetate ion on the left and hydrogen carbonate ion on the right. However, these two can react once again to form the reactants. So this H+, if I'm going to reverse the reaction, I need to give the H+ back to the acetic acid. So this H+ moves from here back onto the acetate ion to form acetic acid. During this process, the HCO3 gave up its proton, so therefore during the reverse process, HCO3- is an acid. Also during the reverse process, my acetate ion accepted a H+. So during the reverse process, the acetate ion acts as a base. The concept of conjugate acids and bases is related to this idea that this substance is an acid, however the product it produces after it loses the H+ is a base. So I could say that acetate is the conjugate base of acetic acid. The word conjugate here is referring to a substance which is paired. The word conjugate does mean pairing. Similarly, I started with carbonate, which is a base, but when carbonate accepts a proton to form hydrogen carbonate ion, the product it forms is an acid. So I could say that hydrogen carbonate is the conjugate acid of carbonate ion. For some more formal definitions, a conjugate acid is the substance formed when a base receives a proton. A conjugate base is the substance formed when an acid loses a proton. You might also see the term conjugate acid-base pair, and that's simply referring to an acid and its corresponding conjugate base. So in our previous example, I could say that acetic acid and acetate are a conjugate acid-base pair, or carbonate ion and hydrogen carbonate ion are an acid-base pair. You might have to recognize conjugate acids and bases from equations, or give equations to represent a conjugate acid conjugate base system. So let's have a look at how we would identify the conjugate acids and bases here. Alright, we've got NH3 reacting with water. The products are hydroxide and ammonium ion. The NH3 during this process is going to gain a H+, it's going to receive a proton, so it is a base. and the conjugate acid of ammonia is NH4+. We could show the fact that these are in a pair by linking them, for example. So these two are a conjugate acid-base pair. Our other substance that was involved in this reaction is water and hydroxide. The water, I can tell that it's going to be an acid, and I can tell that because I know the ammonia was a base. I also could tell it because when it becomes hydroxide, it loses a H+ during the process because it transfers it to the ammonia. So therefore it's a proton donor, it's an acid. With the hydroxide, it must be a base because to reverse the reaction, it's going to need to accept a proton from the ammonium ion. So therefore, the water and the hydroxide is a second conjugate acid-base pair. For this equation, we're going to do the same thing. We're going to find the two sets of acid-base conjugate pairs and label which one is the acid and which one is the base in each pair. If you want, pause the video, have a go at it, and then press play to see the answer. Alright, we're starting off with HPO4 2-, and it ends up becoming H2PO4 -1. So this is going to be accepting a proton to become the product. Therefore, this substance is acting as a base. And if this is a base, then this H2PO4- must be its conjugate acid. So these substances are paired with each other. For the remaining substances, if this is a base, then this must be an acid. If this is an acid, then this must be a base. And these two are the second conjugate acid-base pair.